Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2017, Paper 2, Foundation Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Question 1. Which unit is most suitable for measuring the length of a tennis court? Circle your answer. Okay, well I think kilometres might be a bit overkill and centimetres and millimetres are a bit too small. I'm going to go for metres, that seems the most appropriate to me. Circle multiples of both 8 and 12. Or circle the multiple of both 8 and 12. If I start listing out numbers in the 8 times table, 8, 16, 24 and so on. And do the same thing for 12, 12, 24. Look, we've got one that's matched up there, but 24 isn't one of my options, so it must be one a bit higher up. So let's add a few more to the list. 24, 32, 40. Next one up is 72, isn't it? So I need to keep going up to at least that high. So 40, 48, 56, 64, 72. Okay, so I got to 72 on that one. Can I get to 72 with the other one? 24, 36, 48, 60. Yeah, I got to 72 there as well. So 72 is in both lists and it's one of my choices. So it's that one there. Question 3. What is 3 halves as a decimal? Well, 3 over 2. 2 goes into 3 one time, remainder 1. So 3 halves is the same as 1 1/2. And 1 1/2 is the same as 1.5, isn't it? It's that one there. Question 4. Circle the correct statement. Is -4 less than -3? Yeah, I think it is. I think it's that one. Let's just check the other ones. Is 1 less than or equal to -2? No, 1 is more than -2, isn't it? Is -6 greater than 5? No, it isn't. And is -1 greater than or equal to 0? No, it's not. So it's definitely that first one there that we saw. Okay. Question 5a. Use your calculator to work out the square root of 701 as a decimal. Write down your full calculator display. Okay, so we just need to know how to type into a square root into our calculator. So if you've got one of these Casio calculators, then you can see there's a square root button here. So just click the square root of 701. Now if I press equals, look, it just tells me root 701. That doesn't help me very much. But if I press the symbolic to decimal button, this S to D one here, then it converts it to decimal for me. So it's 26.47 and change it. It wants me to write down the full amount. So let's write down every digit. 26.47640459. Right, then part B says give your answer to part A to 1 decimal place. So I need to round off after the first decimal place. I'm going to round off after that. Just going to check the next digit after the one I'm going to round off. If it's 5 or above, I round up, and if it's 4 or below, I round down. In this case, it's 5 or above, so we're going to round off that 26.4. It's going to round up to 26.5. Okay. Question 6. A swimming pool has 3 changing rooms, male, female, and family, and the pictogram shows the number of people using each changing room during 1 hour. We're told the key, so this towel is representing a number of people. We don't know what it is yet. And we're told that 8 people use the male changing room. So these 2 here, this one and this one, represent 8 people. So that means that each one of those must be 4 each, mustn't it? So 4 and 4 make 8. So our towel represents 4 people. So I've completed the key, so I've done that bit. And then the next part of the question says, how many people use the female changing room? Okay, so we've said each towel represents 4 people. So 4, 8, 12, and I've got a towel with a chunk cut out of it. So that looks like a quarter of it has been cut off. So if the towel represents 4, then each piece must be worth 1, so that's 3 people, isn't it? So altogether I've got 4, 8, 12, and 3 makes 15. So how many people use the female changing room? It's going to be 15 people. 6C says the manager has bought lockers for the changing rooms. Why should he not use these results to decide where to put them? Now I assume what they mean here is that they should put more lockers for the females than the males, because there are more female people swimming, obviously, than the male ones. But this is just 1 hour. All these results were just for 1 hour, during 1 hour of the day, and the day is made out of lots more than 1 hour. And it might just be that this time of the day is more popular with the female swimmers than male, but at other times of the day that might change. So I think I would say that there is not enough information there to make the decision, because it's just 1 hour and not like a whole week's worth of data. So how can I write that down? The data represents 1 hour only, so doesn't give a complete picture of the use of the changing rooms. Something along those lines. There's quite a lot of flexibility with these sort of questions. As long as you can come up with a convincing reason, I think you'll often give credit for these sort of questions. Other suitable responses might have been something along the lines that the sample size is too small because we only got, 25 people. Okay, question 7. Here are a list of numbers: 21, 17, 23, 21, 29, 32, 21, 25, 36. Work out the median. Right, when we're working out a median, the first thing we need to do is put the numbers in order of size, smallest from biggest. So what have I got? I've got 17. Let's put that one down first. The numbers starting with 2. I've got 1, 2 21s, 21, 21. Oh, and another 21, 21. 3 21s. A 23. A 25. What else have I got? I've got a 29, a 32, and a 36. Okay, just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got my 9 numbers down. Okay, so now I've got them arranged from smallest to biggest. Then the median is going to be the one in the middle. So you can either count in from both ends. So like, not that, so counting in from both ends like this until you've got one left in the middle. Or you can say, well, I've got 9 items, add 1, divide by 2. 9 plus 1 is 10, divided by 2 is 5. So the answer is the 5th number. So first, second, third, fourth, 5th value. That's the other way of doing it. Okay, so either count in from both ends until you meet in the middle, or work out where the median should be. Either way, the answer is the same. It's going to be 23. Question 8. Here is a map of a town, and you can see on the diagram here we've got various things marked on it. We've also been given up here a scale. 1 centimeter represents 200 meters, so we can work out how far things are from each other. And we've also been given a direction up here, so this way is north. Okay, so I'm sure that's going to come in useful for the question. What is the question? Which place is exactly northwest of the station? Circle your answer. Okay, so compass points. They've given us north there. You should know that opposite north is south, and then you've got west and east like that. And then between north and east you have northeast. Between south and east you have southeast. Between south and west you've got southwest. And between north and west we've got northwest. So we want to know what's northwest of the station. So northwest is in that direction, isn't it? So if we start at the station and we go northwest, let's just get my ruler out to demonstrate that. So northwest is that direction, isn't it? So starting at the station and going northwest, you can see that the line goes straight to the library. So the answer is the library. Okay, so let's ring that one. Next it says, circle the 3-figure bearing of the monument from the park. Okay, so 3-figure bearings are the angle measured clockwise from north. North is considered to be 0, 0, 0. And then if you measure around to the direction you want to go in, then you can find your bearing. So the 3-figure bearing of the monument from the park. So going to the monument from the park, well, you can see you're going directly to the monument from the park is going directly downwards, isn't it? So let's just mark that on. It's going that direction. Okay, so we said this way is north, so I'm going an angle of 180 degrees around from the north line. So that is going to have a bearing of 180. That one. Any more? Yes. 8C says, what is the distance in meters from the cinema to the station? So cinema to station. Again, I'm just going to join those up with a ruler so I can see them. Now this is a bit of a slant line. So we could measure it, I suppose, because we've got the scale in centimeters. So we can measure it with the ruler and then and multiply it by the number of centimeters by 200 meters, and we'll find the distance. Now my ruler here is a kind of electronic one. It's not going to calibrate nicely with that page, but if you've got a proper ruler on a proper exam paper, you can just measure it to the nearest millimeter. And having done that properly, I made it 5.8 centimeters when I measured it on the real paper with a real ruler. So if it's 5.8 centimeters and I know that 1 centimeter represents 200 meters, if I times 200 by 5.8, I should get the distance. So 200 times 5.8, what's that equal to? Let's reach for the calculator. 200 times 5.8, that gives me 1,160. 1,160 meters, so that's my answer. There's probably a little bit of leeway either side. Probably you're allowed anything from about 1120 up to 1200, I'd imagine, but I made it 5.8, which is 1160. Finally, 8D says, why might the shortest walking distance from the cinema to the station be greater than your answer to part C? Okay, so why might the shortest walking distance from the cinema to the station be greater than your answer? Well, if you come back to the diagram here, you can see that this path is direct, and there might be things in the way. This monument there might be a fence around this monument that you have to then go around. So the actual walking distance might be longer than the direct route, because there might not be a path all the way through. So I'm going to write something like that down. So why might the shortest walking distance be greater than your answer? There may be obstacles in the direct path, so pedestrians would need to walk around these. Something like that. So there may be obstacles in the direct path, so pedestrians would need to walk around these. Question 9. Complete the bank statement. Now I don't know if you've got your own bank account, but if you do, you'll know that credits are amounts paid into your bank account and debits are money going out again, although probably you don't have a lot of experience yet of paying things like council tax. Lucky you. But anyway, so let's assume that you started with a starting balance of £212.48, like we've demonstrated here. A debit of £128.39 is that money coming out of your account. So if I type in 212.48 into the calculator and subtract the £128.39, which is going out, that leaves me with £84.09. £84.09. Okay, next day, this person's salary is paid in, so they're getting paid £856.21. That's a credit, which is money coming into the account, so I need to add that on. So adding on £856.21 gives me a new total of 940.3. 940.3. Now remember, with pounds and pence, we always write those to 2 decimal places because it is pounds and pence. Okay, so the answer is 940.30 and not 940.3. You will get marked down in these sorts of questions if you don't put that extra 0 on. Question 10. The average age of teachers at a school is 36 years. Mr. Smith's age is 11/9 of the average. How old is Mr. Smith? So what we're being asked to find here is 11/9 of 36. So when we've got a fraction like that, well, if you've got a nice calculator like this, you can just type in the fraction, 11/9. Otherwise, you can just multiply by 11 and divide by 9. But I make that 44. So Mr. Smith is older than average. Question 11. Solve 4x minus 3 is equal to 14. 4x minus 3 is equal to 14. Now, the confusion with this is often about which one to move. People will know they have to kind of either add 3 to both sides or divide both sides by 4, but they sometimes get it in the wrong order. You need to attack these in the opposite order of BIDMAS. Okay, so if you knew what x was, let's say you knew x was 2, you'd evaluate it by multiplying it by 4 and then subtracting 3. So when you are unwinding these equations, you need to work back the other way. So going backwards through the list of BIDMAS, I'm going to move this subtraction first. Subtraction I'm going to move before I get to the division and multiplication. So I either change sides, or subtracting 3 from both sides. You're going to get 4x equals 14 plus 3. So 4x is equal to 17. And then either cross multiplying the 4 to the other side or dividing both sides by 4. You're going to get x is equal to 17 over 4. Now, whilst it might not feel like it to most GCSE students, 17 over 4 is actually a very acceptable answer. It's just a top-heavy fraction. If you did want to rewrite it as a mixed number, you can say, well, how many times does 4 go into 17? 4 goes into 17 4 times, and the remainder is 1. So 17 over 4 is 4 1/4. So you could rewrite it like that, or 4.25. You could even type it into your calculator if you wanted to, but 17/4 is actually a perfectly good answer. Question 12. Lee sells ice creams. The table shows the midday temperature of and his sales for 5 days. So we've got temperature and sales for 5 days. Now that has been drawn on a scatter graph. So he's drawn that scatter graph and the line of best fit. What do we think of that? Write down 2 mistakes he has made. Oh joy. So we need to go and check all of these then. So first off, let's check the scales. That he's written those out nicely. So he's got temperature on the bottom. Is that going up in even increments? 0, 5, 10, 15, 20, 25, 30. Yep, that is fine. What about this way? Sales. Is that going up in even increments? 0, 2, 4, 6, 8, 10, 12, 14, 16. Yeah, that seems to be fine as well. Always worth checking the axes first. Next up, has he plotted the points correctly? Let's go through and check each one. Day 1 was temperature 30, sales 180. So temperature 30, sales 180. It's that one up there. So that one seems fine. So we check that one. Day 2, 26 and 150. 26 and 150. That one looks fine. Next one, 17 and 80. 17 and 60. He's plotted that one too low, hasn't he? It should have been plotted here. Okay. Has he plotted the other? Let's just check the other two. So that one was wrong. 22 and 130. 22 and 130 is correct. And 20 and 120, that one's correct as well. So it's just this one here he's plotted wrong. Okay, so my first criticism then is he's plotted that point wrong. So which point was it? It was 1780. So he has plotted day 3, which was 1780, incorrectly. So that's one. The other thing I would say is his line of best fit isn't that great, is it? Now, if you're going to draw a line of best fit here, you want it to go through all the points. And given that he's plotted that bottom one incorrectly, but still, the line of best fit, even if that one was correct, should be heading off much more in that direction. So he's kind of not got his line in the right direction. It's got the right number of points on either side, but it should be angled down more, I think. So I'm going to say his line of best fit does not match well with the plotted points. Question 12b. Lee wants to work out the range of the 5 temperature. His calculation is 30 minus 20, which is equal to 10. Is his method correct? Well, you should know that the range of any given set of data is the highest value, subtract the lowest. Now, the highest temperature given is the one on day 1, isn't it? It's that 30 degrees. That's the highest temperature. And the lowest is this one, 17. So if he's used 30 and 20, he's used the wrong values. It should be 30 subtract 17, which would give you a range of 13 and not 10. So I'm going to say nope, and I've already given my answer because I've worked it out. 12c, the table shows Lee's costs. Ingredients, which is 15% of sales, and fuel, which is £7 per day. Work out his total profit for the 5 days. Okay, so we need to work out how much he sold then, don't we? So we need to total these sales up. So we need to add all these together. 180, 150, 80, 130 and 120. So total sales is going to be all that money added together, which is 180 plus 150 plus 80 plus 130 plus 120, and according to my calculator that is £660. Okay, so ingredients were 15% of sales, so our ingredients is going to be 660 times 15% as a decimal, 0.15. What's that then? 660 times 0.15. That means our ingredients total to £99. And then petrol or fuel is £7 a day for 5 days. So that's going to be 7 times 5, which is, what's that? 7 5s are £35. So then his profit is going to be his £660 that he made, less than £99 in ingredients, and also less than £35 in fuel costs. So reach for the calculator. 660 minus 99 minus 35 gives him a total profit of £526. Not bad going. Question 13. Work out the size of angle X. Now this is not drawn accurately, so we can't just measure it. We're going to have to use the fact that angles at a point sum to 360 degrees. That means if I add all those angles up, I'm going to get 360 degrees. So what have I got then? I've got 21, I've got 160, I've got 36, and I've got that square, which you'll remember is 90 degrees, so don't forget that one. And then I've got my X on the end. And if I add all those up, it should be 360 degrees. Okay? So let's just add up all those numbers on the left. 21 and 160 and 36 and 90. What does that add up to? 160 and 90 is 250, plus the 36 is 286, plus the 21, 287, 307. So that adds up to 307. So we've got 307 plus X is 360. Right, so change sides, take that to the other side, so I subtract it. That tells me that X is equal to 360 subtract 307, which gives me a remainder of 53. So X must be 53 degrees. 53. Question 14. In this question, use 1 kilogram is equal to 2.2 pounds and 1 stone is 14 pounds. Change 70 kilograms into stones. So we're starting with 70 kg, aren't we? So to convert that into pounds, I'm going to multiply 70 by 2.2, aren't I? So what's that equal to? So that is equal to, calculator, 70 times 2.2, that's 154. So that's in pounds now, isn't it? Okay, now 1 stone is 14 pounds. So if I want to convert this into stones, I'm going to have to divide it by 14. So what's that then? Again, reach for the calculator, divide by 14. That's 11. So that's 11 stones. Question 15. Here are some numbers: 10, 13, 15, 20, 27, 39. Now we're told that 10, 15 and 20 is an arithmetic progression. Use 3 of the numbers to make a different arithmetic progression. Describe the rule. Okay, so we've used this number, and this number. So we can pick 3 numbers from the list and make an arithmetic progression from it. Now, an arithmetic progression is just a sequence of numbers going up in even increments. So if you can see here, this is plus 5 and this is plus 5. So can we come up with another sequence of 3 numbers that are equally spaced? Okay, well, let's have a look at the distance between 27 and 39. They are 12 apart, aren't they? So what is 12 less than 27? 12 less than 27 is 15. So I could use 15, 27 and 39. That would work, wouldn't it? So 15, 27 and 39 are my three values. And what's the rule? So the rule is add 12. Now actually there are other possibilities here. You could have equally have had 13, 20 and 27, which is the +7 sequence. So that one would have worked as well. There might be more. I haven't checked all of them. But anyway, there's two that work. Let's move on. Question 16. The counters in a bag are red or blue. 1/5 of the counters are red. Work out the ratio of red counters to blue counters. Okay, so the ratio of red to blue, what is that going to be then? Now we're told 1/5 of the counters are red. So if I've got 1/5 of the counters are red, what proportion is left of that must be blue then? So a whole take away 1/5 leaves 4/5. So that must be 1/5 red, 4/5 blue. Now if I then multiply both of those by 5, then I'm going to get the ratio 1 to 4, aren't I? So the ratio of red counters to blue counters is that one there, 1 to 4. Question 17. Circle the fraction that is equal to 0.1%. Okay, now a percentage is a fraction over 100, so 0.1% is 0.1 over 100, but we can't really have 0.1. Fractions need to have whole number numerators and denominators. So if I times top and bottom by 10, if I do that to a fraction, I don't change its value, just change its form. So 0.1 times 10 is 1, and 100 times 10 is 1,000. So the fraction equivalent to 0.1% is that one there, 1,000th. Question 18. Ellen works for a company that sells cars. Her monthly pay is a salary of £1,470, 28% of the total profit the company makes from her sales, and a £250 bonus if she sells at least 15 cars. The table shows information about the cars she sold last year. Okay, so the total cost to the company was £464,500. The total income for the company was £538,000, and the number of months when she sold at least 15 cars was 3. Was Ellen's total pay for the year more than £40,000? You must show your working. Okay, so let's work out the various parts of her salary and then add them all up. Okay, so her monthly salary was, so this is per month, isn't it? So she's getting a salary of £1,470. So over the course of the year, she's going to get that paid 12 times, isn't she? For once every month of the year. So 1,470 will be her salary. So yearly salary is 1,470. 1,470 times 12 months of the year. And what's that equal to? Calculator. What is 1,470 times 12? Apparently it's £17,640. £17,640. Okay, so that's her yearly salary that she gets guaranteed. Now the rest of her salary is performance related. So she's getting 28% of the total profit of the company. 28% of the total profit the company makes from her sales. Now the total cost of the company of her sales was $464,500, and the total income for her sales was $538,000. So then the profit the company made is going to be the difference between those two. How much money it had coming in, less the amount of money it had going out. So what's that then? So company profit is going to be 538,000 subtract 464,500. So tap in again that into the calculator. 538,000 subtract 464,500 comes out to 73,500. £73,500. That's how much profit the company made out of those sales. Now, she gains 28% of the profit. So her percentage is going to be that 73,500. Well, we want to work out what 28% of that is. So we're going to use the multiplier 0.28, rewriting that percentage as a multiplier, and then multiplying through by it. So 73,500 times by 0.28 means that her commission then was £20,580. £20,580. Okay, so that's her percentage she gets on the sales, plus her bonus. Now her bonus is £250. Oops, £250 bonus if she sells at least 15 cars. Now we're told that there were 3 months where she sold at least 15 cars, so she's going to get that bonus 3 times over, isn't she? So her bonus is going to be £250 times the 3 times that she earned it, which is £750. Okay, so her total pay is going to be then her salary, which is 17,640. Her commission on the sales, which was 20,580, plus her bonus of 750. So adding all that up, plus 750 plus 17,640. I make that a grand total of 38,970. Okay, so what was the question? After you do a big long calculation like that, it's always good just to double check what the question was, because you'll probably forget at this point. Was Ellen's total pay for the year more than £40,000? Well, to answer that question then is no. No, she earned less than £40,000. Question 19. Ben and Katie throw darts at a target. Ben's ratios of hits to misses is 5 to 1, which means he's getting about 5 hits for every 1 miss. Katie's ratio of hits to misses is 3 to 1. Ben says 5 is bigger than 3, so I must have more hits than Katie. Give an example to show that this might not be true. Okay, so a ratio is just the amount of hits to misses. So let's say that Ben threw 6 times. So if Ben throws 6 times, then he has 5 hits and 1 miss. Okay, so let's have a look at Katie. She hits 3 times for every 1 time she misses. So 3 plus 1 is 4. So in the 4th row, she hits 3 times and misses once. But let's say she did that over again. So she hit another 3 and missed another 1. That's a total of 6 hits and 2 misses. So Katie could throw 8 times, gaining 6 hits and 2 misses. Okay, so we've given an example, haven't we? So we've given an example to show this might not be true. So if Ben throws 6 times, he gets 5 hits and 1 misses. and Katie could throw 8 times, gaining 6 hits and 2 misses. So she's hit more times than he has. Question 20. A code has 4 digits. Each digit is a number from 0 to 9, and digits may be repeated. The code starts 541, and then there's another number to it. So Joe chooses a number at random for the last digit. Write down the probability that he chooses the correct number. Well, probability is successful outcomes divided by total outcomes, isn't it? So how many different outcomes are there that are possible? Well, he's got a choice of 10 digits, isn't it? Numbers 1 to 9 plus 0 is 10. So he's got 10 choices. One of them is going to be the correct answer, and the other 9 are going to be incorrect. So there is one successful outcome. So then the probability then that he chooses the correct number is going to be 1 in 10. Okay, so answer is 1/10. Amy knows that the last digit is odd, but not a 7. She chooses a different odd number at random. What is the probability that she chooses the correct number? Okay, well, we know that probability is equal to successful outcomes over total outcomes. Now, in this case, she knows that the last digit is a odd number. The odd numbers are 1, 3, 5, 7, 9. But she already knows it's not a 7, so she's not going to randomly pick 7. So she's going to randomly pick from 1, 3, 5, and 9. So she's got 4 possible outcomes, only one of which is going to unlock the door. So her probability of success is 1 out of 4. 1/4. Question 21. Eva thinks she can save water by having a shower instead of a bath. Eva's shower uses 10.8 litres per minute and lasts for 8 minutes. Eva assumes that the water in her bath is the shape of this cuboid. So we're given the dimensions of that cuboid, and we're told that 100 centimeters cubed is 1 litre. Using Eva's assumptions, work out how many litres of water she saves by having a shower instead of a bath. Okay, so how much water does she use for the shower? So water used for the shower is going to be 10.8 litres per minute for 8 minutes. So 10.8 times 8. 10.8 times 8, according to my calculator, is 86.4 litres. Okay, right, now let's compare that with the amount of water she has in the bath. So she's assumed that the bath is a cuboid with those dimensions, so then the volume of this cuboid is going to be those 3 measurements multiplied together, isn't it? Length, width of height, and times height is the volume of a cuboid. So let's multiply those together. 110 times 50 times 35. What does that come to? So 110 times 50 times 35 gives me 192,500. 192,500. What's the units going to be? Centimeters times centimeters times centimeters. It's going to be cubic centimeters. Now it's time to use this conversion factor here. 1,000 cubic centimeters is 1 litre. So if I've got that in cubic centimeters and I want litres, I need to divide through by 1,000. So, So again, reaching for the calculator, divide by 1,000. I'm going to get 192.5 litres. So that's equal to 192.5 litres. So then the water saved is going to be the difference between those two then, isn't it? It's going to be 192.5, the amount of she's had in the bath, less 86.4. Subtract 86.4. So again, reaching for the calculator, 192.5 minus 86.4. That gives me a total saving of 106.1 litres, which is quite significant, isn't it? So it's less than half as much then. That's definitely a good saving. Okay, and that's assuming, though, her assumptions are correct. This is part A, though. I wonder what part B is going to be. Okay, so part B says A shows the water level before it either gets into the bath, and B shows the cuboid in the empty bath. What does this tell you about the amount of water saved? So I would say that the cuboid, this is the cross section of the cuboid, isn't it, here? This is the cross section of the cuboid. So that is clearly an underestimation of the water in the bath, because you've got all this extra space around the edge that we haven't accounted for. Okay, so given that we have assumed that the cross section is smaller than it actually is, that's going to be this one here, that's going to be smaller than it actually is. That means that cuboid is going to have a greater volume than it should have, which means that the water saved is going to be even more than that, because this is going to be higher than it was. This is higher than it was, so this is higher than it was, so this is higher than it was. Okay, so she's going to save more water. So what does that tell us about the amount of water saved? It tells us that she has underestimated it. The amount of water saved. Question 22. I'm given a right angle triangle here, of which I know two sides and one is labelled x, and I'm asked to work out the value of x as a decimal. Okay, so the rule that links three sides of a right angle triangle together is Pythagoras Theorem. So I'm going to be using Pythagoras. So using Pythagoras Theorem, I know that c squared is equal to a squared plus b squared, where c is the longest side, so that's going to be c, and a and b are my shorter sides. So subbing in those things in, I know that, well, let's just rearrange it first. Do I want to rearrange it first? No, let's sub in. So 8 squared is equal to 3 squared plus x squared. So I want what x squared is, so let's rearrange that. Let's move the 3 squared over. So then x squared is equal to 8 squared minus 3 squared. So what is 8 squared? That's 64, and 3 squared is 9. So x squared is going to be 64 subtract 9. 64 subtract 9 is 55. So then x is going to be the square root of that then. So x equals the square root of 55. Reach for calculator. Root of 55 as a decimal. Work out the value of x as a decimal. Should really round this off. I'm not going to write it all down. Unless otherwise stated, I normally write decimals down to 3 significant figures. So in this case, it would be 7.42. 7.42. What's the units? Centimeters? Lily goes on a car journey. For the first 30 minutes of her journey, the average speed is 40 miles per hour. She then stops for 15 minutes, and she then completes the journey at an average speed of 60 miles per hour. The total journey time is 1 hour. Okay, so let's just quickly sketch, before we draw the graph properly, let's just quickly sketch out what we're expecting. So she's going to start at 0, 0, and she's going to travel for 30 minutes at an average speed of 40 miles an hour. Now, that should be a straight line section then, shouldn't it? Which takes us up to, well, we're going to have to work out what that height is here, aren't we? And then what happens, she's going to be stationary for 15 minutes, and then she's going to continue on her journey at 60 miles an hour. So we're expecting a steeper section of the graph up here that terminates at a time 60. So that one was 15 minutes. So that's at 45, isn't it? Okay, so what do we need to do? We need to work out that height for where she'll be after the first 30 minutes, and we'll also have to work out that height there then, what time, where she's going to be after 60 minutes. Okay, so let's do that then. So for the first 30 minutes, her average speed is 40 miles per hour. So if she can do 40 miles in 1 hour, then in half an hour, she's going to be able to manage half that distance, isn't she? So at a time of 30 minutes, she will have traveled 20 miles. So I'm going to plot 2 points straight away. I'm going to plot 0, 0. And at 30 minutes, she's going to be at a distance of 20 miles. So I'm going to have a point there. She's then going to be stationary for 15 minutes. So I'm going to have a flat line between that point and that point there. And then she's going to be traveling at 60 miles an hour for the next 15 minutes. So if she can do 60 miles an hour, then 15 minutes is a quarter of an hour. So she can go quarter of that distance in 15 minutes. So a quarter of 60, half and half again is 15. So she's going to do 15 miles in 15 minutes. So if she's at a distance of 20 and she travels for 15 miles, she's going to now be at a distance of 35. So I'm going to plot a point at 60, 35. Okay, so now I just need to join those all up with straight lines. Done. Okay, so my graph looks like that. Write down the average speed for the total journey. Okay, now you remember from your DST triangle that if I want to find speed, then speed is going to be equal to distance traveled divided by time taken. So we know that she traveled for an hour, so that's going to be 1. That's going to make our dividing very easy. So how much distance did she travel then? So she started at 0 and ended up at 35. So she's traveled a total distance of 35 miles in 1 hour, giving her an average speed for the entire journey of 35 miles per hour. The pie chart shows information about voters in an election. You can see that more women than men voted. Almost twice as many women than men. Or was it more than twice as many? 3,360 more women voted than men. So work out the total number of voters. Okay. So let's say that number of men voting was X. Then 3,360 more women voted than men. Then women voting must be X plus 3360. Okay. How does that help us? Right, and then I suppose we can use the angle then to work out the rest. Well, what's this angle here? We've got 360 degrees in a circle, so less 110 gives us an angle for women of 250. So I suppose we could use that as a ratio of women to men, can't we? We can say that the ratio of women to men is 250 to 110, and we know that then that is X to X plus 3360. Okay. So the difference in their angles then is 250 take away 110, isn't it? So 250 take away 110 is 140. I'm still trying to think about how best to do this problem. So 250 minus 110 is equal to 140. And then I suppose then that 140 degrees must be that extra 3,360 people then? Okay, I think we might have got onto it now then. So 140 degrees represents 3,360 people. So I'm going to use a method known as the unitary method, or going via 1. If I divide this by 140, I will then find out how many people represented by 1 degree. And then if I then times that by 360, I'll know how many people are represented by 360 degrees. So let's do that then. So 3360 divided by 140 times by 360 gives me an answer of 8,640. So there are 8,640 voters altogether. Okay, we've got there in the end. The table shows some information about some CDs. A CD is chosen at random. The probability that it's rock is 1 out of 20. Work out the probability that it is jazz. Okay, so we've got this table. We've already got some information on it. So the number of CDs for a rock is 2, and the probability of selecting it is 1 out of 20. So what does that tell us? So probability is successful outcomes over total outcomes. So there are 2 rock CDs. So probability is successful outcomes over total outcomes. There are 2 rock CDs, and we know that the probability is 1 over 20. So that means there must have been 40 total outcomes then, so that 2 over 40 can cancel down to 1 over 20. So there must be 40 CDs altogether. Okay, so what is the probability then that it's jazz? Okay, well the next part is slightly algebraic, isn't it? I've got x and 2x plus 5 now, and I know there are 40 altogether, and we know with probability that probability sums to 1 if you look at all the options, isn't it? It's because of completeness. So this 1/20th plus the other 2 probabilities is going to add up to 1. So we can form a linear equation in x here. We can say that our probability of x over 40 plus 2x plus 5 over 40 is going to be equal to 1 minus probability of getting a rock CD, which we said was 2 out of 40. So 1 subtract 2 out of 40 is 38 out of 40, isn't it? So I've got x over 40 plus 2x plus 5 over 40 is equal to 38 out of 40. Now, just multiplying through everything by 40, I'm going to get rid of those 40s on the bottom. That's going to give me x plus 2x plus 5 is equal to 38. So collecting like terms, 3x is equal to 38 subtract 5. So 3x is 33, making x equal to 11. So what is the probability then of getting jazz? So the probability of jazz then is going to be, well, we're told it's 2x plus 5, aren't we? So 2x plus 5 over 40, where x is 11. 2 11s are 22, plus 5 is 27 over 40. So my answer, 27 over 40. Complete the table of values for y equals x squared minus x minus 2. So they've given you some of the values and they want you to find some more. Now it's usually a good idea to start with a positive end because that's a little bit easier to work out. And you might want to just double check your understanding by picking firstly a pair of values that you do know both of, just to make sure you understand what it is you're meant to be doing. So if I did input 3 into this function, I would get 3 squared minus 3 minus 2. 3 squared is 9, take away 2 is 6, take away 2 is 4. Yeah, so that's right. Okay, so that is what I'm going to be doing for each of these questions. So then if I put 2 squared in and I take away 2 and then another 2, 2 squared is 4, take away 2 is 0. And then I've got minus 2, minus 2. Can you see it's repeating itself? So that's probably the point where it turns around and starts going up. So I'm already thinking this is 0 and 4 here, but I'm just going to double check. So put minus 1 in, minus 1 squared minus negative 1 minus 2. Negative 1 squared is positive 1. Take away negative 1 is positive 1. So that's 1 plus 1. Take away 2 is 0. So yeah, that is 0. And then for minus 2, minus 2 squared minus negative 2 minus 2. Negative 2 squared is positive 4. Minus negative 2 is plus 2. So that gives me 6. Take away 2 is 4. Okay, so it is what I thought it was going to be. Right, so draw the graph of y equals x squared minus x minus 2 for the values of x from minus 2 to 3. So basically we just need to plot those points on. Minus 2, 4. Minus 2, 4 is up here. What's next? Minus 1, 0. Minus 1, 0. 0 minus 2. 0 minus 2. 1 minus 2. 2, 0. And 3, 4. Okay. Now this was a quadratic equation, so we were expecting a parabola, and that is what we've got. So I'm feeling pretty confident here that we've got it right. The last part is to draw a continuous curve passing through each of your points. You don't have to be Leonardo da Vinci, but try and get it to be as smooth as possible. What you don't want to be doing is put in like 2 marks on your paper. That will get marked down. Okay, and make sure you're using a reasonably sharp pencil. And make sure you go through each of the points. I'm a bit off on that one actually. It's good to go through the center of each one. 6C says write down the x coordinate of the turning point of the graph. Now my turning point is this point here, isn't it? That's where the graph stops going down and starts going up again. Now we only want the x coordinate, so just reading up to the line, I can see that that's going to be at a half. So the x coordinate is a half. Interestingly, they don't want the y coordinate here. Okay, done. Write these numbers in descending order. Now whenever they write anything in bold, it normally means that students tend to miss over it or skip over it. So descending means going down, doesn't it, from biggest to smallest. So I've got 3 numbers, 2 of which are in standard form. So let's write those out long then before we proceed. So 10 to the 3 is the same as 1,000, isn't it? And 9.56 times 1,000, it's going to be 9,560. Oh, 9.56 times 3 to the 10. Ew, what on earth is that? Right, 3 to the power of 10 is 59. Well, that's huge. Times 9.56. That's enormous. 564,508 roughly. So I think it's clear to say that that one is going to be the big one. So that is 9.56 times 3 to the power of 10. And then, which is the next biggest? Or the next smallest? It's going to be the 9,563, and the smallest then is 9.56 times 10 to the 3. Notice I put them back into the form that they gave me at when I wrote down the answers. Question 28. Rearrange y equals x over 3 plus 9 to make x the subject. Now, the rules for these are very similar to solving linear equations and things like that. If you were to evaluate an expression like 9 over 3 plus 9, you want to work this out. BIDMAS says do multiplication and division first, so you would do the dividing by 3 first, and then you would do the addition and subtraction, so then you would add the 3. When you are rearranging equations and when you are solving equations, you have to kind of work backwards through BIDMAS. So starting with y is equal to x over 3 plus 9. Now, so like I was saying, if I was evaluating this, I'd divide by 3 first and I'd add on the 9. So going backwards through that, I'm going to deal with the plus 9 first. So I'm going to move that to the other side of the equation. You need to remember to change sides, change signs. So if it's on a plus on the right hand side of the equation, if I move it over to the other side, it becomes subtract. So I get y subtract 9 is equal to x divided by 3. Next thing is the divide by 3. I've got to cross multiply that. So I'm going to take this 3 down here and I'm going to cross multiply it to the other side of the equation. So divide by 3 on the right hand side becomes times by 3 on the other side. Now I'm going to multiply everything on the other side by 3. So I need to show that by putting some brackets around y minus 9. Otherwise it would just be I'd only be multiplying the 3 with the y if I didn't put the brackets in. So the brackets got to go in, and there we have it. So just spinning that around, put x at the beginning, x equals 3 open brackets y minus 9. Question 7. Use trigonometry to work out the length x. I tend to remember ratios using the mnemonic SOHCAHTOA. Maybe you've got a different way. Maybe you can share it in the comments if you do. Right, so let's label up the sides. Here's my angle. This is the longest side, so that must be the hypotenuse. X is opposite my marked angle, and the other side is adjacent. Now, which ones am I using? I'm using the hypotenuse and the opposite, so the ratio I'm going to be using is sine. Okay, so the sine of my angle, sine theta, is equal to opposite over hypotenuse, which in this case, my sine 72 is going to be my x over 8. Rearranging for x equals, what we're going to do is move that 8 up there. So x is equal to 8 sine 72. Reaching for the calculator. Sine 72. Make sure your calculator is in degree mode. That could be a terrible, terrible mistake otherwise. Sine 72 times 8 is 7.608. I'm going to round that off to 3 significant figures. Does it tell me to do that? Nope. If it doesn't say, then 3 significant figures is usually a good one to go for. So I'm going to round that off to 7.61. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.